This lecture is being brought to you in part by the generous gifts of these sponsors.
Well, that was quite an introduction, and I hope I can live up to half of that. But I first wanted to say thank you to the organizers of this conference, Dr. Ford and Lori, for the kind introduction to come back here and talk. And I hope what I have to say will be of interest and value in terms of practical life changes that you can consider making after this talk. All right, so. I'd like to start by giving an outline of what I'm going to talk about. So the first part of the talk will be relatively briefly, but talk about the factors that we know influence changes in function that occur with aging and with the focus on metabolic processes, what we can learn from the biology of aging, and how that can inform our life decisions and how our cells actually become more resilient through the process of stress and recovery. And then lifestyle factors that can produce positive adaptations and help us become more resilient humans. And then some conclusions and future directions from there. Okay. So first, I want to talk about what is aging lifespan versus health span. I'm not sure how many folks have heard the term health span, but let's just get our terms up front. And talk about what aging is and how I define it, or how many people define it, as a progressive changes that lead to or can lead to a decrease in physiological function and to a decrease in age-related fitness. Generally, what we consider is the condition, our goal is to be physically fit and healthy, and from a biological standpoint, the idea is to be able to survive and reproduce within a particular environment. What my research and much of the research at the Institute on Aging focuses in on is the health span, and that's defined as the length of time that a person is healthy and functional, has a high quality of life, and not just alive. Okay, and so from our perspective, the goal is really to be able to help people follow the upper line. The trajectory shown in the upper line is what is a person, an example of a person who basically maintains high levels of function throughout their entire life, through middle age and into their older life. And so you can see the trajectory is a relatively slow decline, if any, over time, where they maintain independence and are highly engaged in society. Unfortunately, that is not the typical trajectory. The typical trajectory, or more, I should say, a common trajectory, is, unfortunately, a common trajectory is more the lower line, where you see that over the course of one's life, there's a relatively rapid or clear decline in function that can ultimately result in the development of a disability, either cognitive disability or physical disability, that leads to the need for assisted care of some sort. And as you can see by this dual arrow here, a lot of times that's because the relative strength of an individual declines to the point where they're unable to maintain their mobility. And of course, environmental changes can lower the threshold at which a disability occurs. So that is just a big picture. Now, what are the factors that can influence mobility as we age? This I put here because I think it's a common occurrence that I can relate to, and many people probably can relate to. With aging, sometimes some of the activities that we used to do, unfortunately, become more challenging. Maybe some physical activities lead to an experience of discomfort, or we wake up feeling more stiff or sore, and as a result, maybe we decide, oh, I should avoid that because I don't like feeling sore and and having discomfort. But unfortunately, the downside of that is that leads to the reduction in physical activity can lead to increased risk of unhealthy weight gain, which I'll get into in the next slide in a bit. and create a cycle whereby the activity becomes even less enjoyable, more painful, and thus promoting this unhealthy cycle. And part of the reason this cycle can occur is because many times what we see is our total energy expenditure starts to decline with aging. That's a function of three main things. One is a decline in lean tissue or muscle mass. And the reason that contributes to a decline in total energy expenditure is because the lean mass is what really drives what's called our basal metabolic rate, okay? And so when you have less lean mass, you have a lower basal metabolic rate. In addition, with the reduction in physical activity, an important other component of total energy expenditure that also contributes to reduction in total energy expenditure. And then the mitochondria within the cells start to actually produce less energy. And so the combination of those three factors leads to a reduction in total energy expenditure as we age, which is unfortunately not proportional to the reduction in our eating, or our drive to eat. So the natural consequence of that would be weight gain. And that can be for these reasons, it can be relatively easier to gain unhealthy weight as we age than it maybe was when we were younger. Okay. So in addition to weight gain, there's this other challenge. And of course, the first parts of my talk are depressing, but I promise after we get through the first part, it gets a little less depressing and hopefully more uplifting. But in this slide, what I'm showing you here is a hypothetical person and comparing what their body composition looked like at age 25 versus age 70. And so this person hypothetically had the same height and weight, but they're fundamentally different. As you can see at age 70, now this person's body composition is comprised of approximately 30% fat versus 14% when they were 25. And the amount of lean tissue is proportionally much lower at the age of 70 than at the age of 25. Now, if we just looked at that person's height and weight, many doctors might say, well, you're healthy because you're in the healthy weight range. But for older adults in particular, I believe it's important to look at the body composition because it's possible to have a body mass index in the healthy range, but not necessarily the healthiest body composition. Okay. And these series of factors can lead to increased risk of what's known as the metabolic syndrome. How many people have heard of the metabolic syndrome? Okay, so almost everyone. And this is a condition that's diagnosed when a person has 3 or more of the risk factors that I have up here: abdominal obesity, high insulin levels, high fasting plasma glucose levels or impaired glucose tolerance, high triglycerides, low HDL, or hypertension. So the person doesn't have to have all of these risk factors, or any particular combination, but 3 or more is usually what's needed. Generally speaking, the hallmark of this syndrome is a waist circumference, an elevated waist circumference. For men, it's 38 inches or greater, and for women, 34 inches or greater, and impaired fasting glucose, or high fasting glucose. And why do I bring this up? Well, I bring it up because in contrast to obesity, which we see progressively increases across all segments of the adult population, what you can see from this figure is that the proportion of individuals who have the metabolic syndrome dramatically or progressively increases with increasing age, such that by the time a person's close to 50 or in their 50s, almost 1 out of 2 individuals would be diagnosed with having this syndrome versus individuals who are below the age of 30, where less than 10% of those individuals would have this syndrome. And why that's important is because having this syndrome has been clearly related to risk or the development of type 2 diabetes, heart disease, as well as increased risk for mortality from all causes, and dramatically increased risk, approximately 5 times increased risk of individuals who have the metabolic syndrome versus those who don't. So it's something to be aware of. In addition to the physical potential negative effects that carrying the extra weight can have and the metabolic disruption, I'd like to present this nice review article that highlighted the connection between our metabolic states and our brain's aging. And I'll just show you a figure that I really liked from it. And at first it may seem or look overwhelming, but what I really wanted to highlight is that there are a number of potential mechanisms that we know are related to brain aging and cognitive decline over time, which you see in the outer regions of this figure. But what I wanted to focus in on is the inner circle, which says dysregulated energy metabolism, which to me told the story that by dysregulating our metabolic processes, we are essentially increasing risk of many of the mechanisms that we know are related to brain aging. So conversely, if we can find a way to regulate our metabolic processes, we have the potential to reduce risk of many of the age-related cognitive conditions. This talk isn't focusing too much on this, but I wanted to at least highlight that part of it. When we think about our lifestyle, as we're going to get into, I'd like this figure because it provides kind of a broad overview of what can happen and lead to the development of metabolic syndrome as we age. So in this figure, which was taken from the article below, showing this cycle that can occur by engaging in unhealthy lifestyle habits such as eating fast food, not exercising, sedentary behavior long-term, not sleeping well. All of these we know contribute to elevations in ROS, which stands for reactive oxygen species. And when we have these reactive oxygen species elevated, we know that can contribute to the risk factors for cardiometabolic disease, which are listed here: insulin resistance, visceral obesity, which is the fat within the midsection, hypertension, dysglycemia, and dyslipidemia, so elevated blood lipids and elevated blood glucose. And so when that occurs, all of this starts to increase risk for metabolic syndrome, as well as unhealthy or accelerated aging processes, which in turn feed back and increase levels of reactive oxygen species. And so you can see that to prevent this or to slow this process, we want to start by intervening at the unhealthy lifestyle part. Now, of course, our diet and exercise are very important, but I want to put this figure up here to highlight the complexity and how complex we are, how many different influences there are on our actual gene expression and what's called epigenetic modulation. We certainly, what we do from an activity standpoint, what we eat, influences our gene expression, but also our psychological state, our social interactions or interactions with other, what types of treatments we receive, either traditional or alternative, our microbiome, some changes that can occur with different seasons, our exposure to different diseases, our exposure to toxic chemicals, whatever drugs we may use or hopefully not, but potentially abuse, and our financial status can all have an influence on our genetic gene expression and contribute to what we as humans are experiencing. And so it's obviously very complex to think through, but I just want to highlight the multiple influences to keep in mind. And then when we are thinking about what factors change over time that may influence our actual function or our mobility, this may look somewhat familiar because there's an overlap, not surprisingly, between the factors that affect our brain's rate of aging and factors that may influence our mobility or our physical function over time. And as you see here, there's the epigenetic alterations, the genomic instability, the altered cellular communication, stem cell exhaustion, cellular senescence, telomeres, which were the big focus for many years and still very important, dysregulated nutrient sensing, which we're going to talk about. And then I want to talk a little bit more right now about the mitochondrial function or dysfunction and how important that can be to our health. Does everybody know what I mean by mitochondria? Good, okay. So the mitochondria are actually I'm just going to go to this slide for 1 second and then we'll back up. The mitochondria are what are considered the powerhouses within our cells that are the ones that produce the energy that our body utilizes, the ATP molecules that turn into energy within our cells. And so that when we have healthy mitochondria, we feel good, we feel energized and ready to take on activities. When our mitochondria are not as healthy, we may experience symptoms such as fatigue, difficulty focusing, etc. And so what I want to highlight is part of this talk is the importance of maintaining healthy mitochondria. And so what I believe is that if we can modulate the pathways that are associated with healthy mitochondria, we have the potential to prevent or decrease risk of many of the age-related diseases, and so that they're essentially very important for maintaining long-term health. Without healthy mitochondria, many of the disease conditions that you may be familiar with could occur, and they've been linked to chronic inflammation. And that's because when the mitochondria aren't functioning in as healthy a manner as possible, they can actually increase levels of reactive oxygen species and inflammation at the cellular level. And so you've probably heard how risky it is to have high levels of chronic inflammation, or how important it is to keep inflammation lower. One of the factors is to keep your mitochondria as healthy as possible so that they don't flood your system with these challenges, so to speak. Okay, and so when we take a step back, we think, okay, what are the factors that are affecting the function of the mitochondria? And a big one is this energy metabolism. And by that, we start to look at the role that our lifestyle has in terms of when we're eating, what we're eating, how much we're eating, but also when we're exercising, how much we're exercising, and what we're doing for exercise. And obviously, sleep plays a critical role too. Those are the big three I showed you in the previous figure. Those are not the only big three, but are the only factors to keep in mind, but they are the biggest ones. And so ultimately, if we can keep the mitochondria as healthy as possible by keeping this energy supply and demand balanced, we can benefit from that by maintaining higher levels of function. And what I want to move towards is talking about this imbalance, which often occurs through unhealthy lifestyle choices, and how we can change this imbalance through a process that is called hormesis. Now, we're going to show you that shortly, but what that really is the importance of temporary challenges, such as physical activity, calorie restriction, or intermittent fasting. All of these temporary challenges can induce this cellular process called hormesis, which actually results in healthier cells And so what I want to move towards is showing you in this type of figure how when we present our cells, or in this case our mitochondria, with a temporary stressor, they actually become stronger, provided we have given them, our body, our cells, the ability to recover. And then we have both increased ability to fight disease and free radical damage, but also the mitochondria are not secreting as many free radicals themselves. Okay. Now, many of you might be saying at this point, I don't want to do that. I just want I just want to rest. And I'd love to tell you that you could, and you could experience all the great benefits from just resting. But unfortunately, at least science that I know does not support that answer. And this is findings from a study that was published in 2019, where they took healthy young adults who agreed to participate in a bed rest study where they essentially were under bed rest for a 3-week period of time, and they looked at what happened to some of their physiological changes. And what you can see is that after this 3-week bed rest, their VO2 max, their maximum oxygen uptake in a test, declined by 27%. So these were individuals at peak condition, basically, going into this. They also had the good news was that when they retrained, they had an increase of 45%, so they were able to restore their function. But their maximum cardiac output declined by 26% after bed rest, but then it improved after the training. And basically, their baseline VO2 max had declined by 12%, so they followed these same individuals for a 30-year period and showed that over that time period, their VO2 max declined by only 12%, in contrast to a 27% decline from the 3 weeks of bed rest, which, as I put in bold here, shows that 3 weeks of bed rest for individuals at age 20 years of age reduce cardiovascular capacity more than 30 years of aging, more than twice what 30 years of aging did. So unfortunately, that means that rest is not our best option if we want to stay healthy and resilient. And then I just put this here because in this day and age, we all have the ability to not move too much. We have the ability to sit and work on computers, sit and watch TV, order food from our computer, and I'm as guilty as this as anybody. But the option is there to not necessarily be physically active, in contrast to in the past when activity was just built into our way of life. So that means that we have to make a choice to actually move throughout the day to not experience some of these negative effects. On the other hand, if we go and over-exercise, kind of like as I showed before, we may feel very sore. The workout can feel difficult. We might not sleep well. It may affect other parts of our lives. We may experience digestive issues or have aches and pains, feel sick, and none of this sounds very appealing either, right? So that leads us to the question of what to do. And that's what I want to focus in on for the remainder of the talk. So I mentioned the word before, hormesis. And this is the concept that there's an optimal level of stress that produces positive adaptations, that too little stress doesn't produce too many adaptations, but too much stress can lead to exhaustion, can lead to fatigue, it can lead to illness. And so it's most easy for most people to grasp this concept with exercise, because for most of us, we've experienced what it feels like to overdo it or maybe to underdo it. And so there's this zone where if we can figure out what the right stimulus is, what the optimal amount would be, that we start to experience a number of benefits, including, reduction in reactive oxygen species, increase in our body's ability to produce antioxidants, reduction in oxidative damage, but an increase in our ability to repair our tissues. And so if we're able to stay within this zone, then we're going to experience many of these beneficial effects. On the other hand, if we go out and we are somebody who hasn't really run in the recent past, and we go try to run 5 miles, that's likely going to lead to many of the negative effects, because that would be too much stress too soon, and that could result in a number of negative outcomes. On the other hand, if we are somebody who is capable of running 3 to 5 miles, and we maybe go and walk 1 mile, well, that's not probably going to produce too many positive effects on the system because we didn't really challenge it. So there needs to be some level of challenge that produces positive adaptations. And so I've talked a good bit about hormesis, but you can now see it on the board where the way I like to define it is temporary stress that induces adaptation at the level of the mind and body. And exercise is one example of a hormetic stressor, but it's definitely not the only type. Other types are, for example, cold exposure. You've probably heard a lot of people talking about cold baths and ice baths and how those can produce beneficial effects, and I think they probably can in the right dose. Similarly, heat exposure, such as saunas or steam rooms, can produce beneficial effects in the right dose. From a dietary standpoint, intermittent fasting or ketogenic diets or maybe even calorie restriction can stimulate cellular pathways that have powerful effects in supporting our overall health. So ultimately, it's a balance between stress and recovery. And we'll get into that more. But I wanted to make the point that nutritional stress by stress, I mean these diets that challenge our cells to adapt, can be not only a way to improve our energy metabolism, but also reduce inflammation and help our cells adapt to stress in the future. And by repeating mild to moderate stress, that ultimately can have beneficial effects on the organs in our system as well. Now, this slide may look like a lot, but I'll walk you through it. It comes from a nice review article published by Paoli in Nutrients, and it's illustrating the point I was trying to make, that what you see here is, in this figure, there's green, oh, sorry, I'm hitting the wrong button. Green for arrow represents the effect of fasting. The blue arrow represents the effect of calorie restriction, and the green arrow represents the effects of the ketogenic diet. Now, this was their conclusions of this review, so it's not gospel, but it was an interesting conclusion. The length of the arrow represents the strength of the evidence at the time of this review for how each of these dietary interventions could affect what are known factors to affect the biology of aging. So you've probably heard about inflammation, which we talked about. As you can see, all three would have a positive effect in reducing levels of inflammation. They would all three affect the production of reactive oxygen species, with fasting and the ketogenic diet, in this case, having stronger effects or more consistent effects than calorie restriction. They can all affect the process of autophagy. How many people have heard of autophagy? Okay, a few. Autophagy is the cellular process by which our cells remove damaged particles and waste products. Without this process, our cells become full of unhealthy substances and are unable to function as effectively as we would want them to. It's critical to our health and survival, and the Nobel Prize was actually awarded to the individual who discovered this cellular process in 2017. So it's a very, very important process. In addition, we see the effects on mitochondrial biogenesis, the production of new mitochondria. All three of these interventions can affect the production of healthy new mitochondria. They can affect our immune system. They can potentially have an effect on this IGF-1 growth hormone axis, because too much of this particular hormone, IGF-1, is thought to be contribute to less beneficial function. They can affect the microbiome. And then here we go to my favorite, the hormesis hypothesis. And each of these, as you can see, with fasting and calorie restriction, thought in this review to having a bigger contributing factor to hormesis, that the low levels of stress actually prime our DNA to repair the genes that then lead to maintenance and repair of the cell's mechanisms, which ultimately result in them being more resistant to stress. So it's at the cellular level that this process is actually taking place. I hope I was able to walk you through that particular challenging slide. Good. So in the same review, they proposed what they thought represented the healthiest lifestyle. Some of this, most of it I agree with, but maybe not every part of it. But you can see that the compare and contrast here, where the individual, I think would be on your left, I believe, would be someone who eats 2 to 3 meals daily. In this case, they propose he or she eats breakfast and has their last meal relatively early in the evening. So they avoid late night eating. They have protein content at most meals, and on a daily basis undergo 12 to 16 hours of fasting. So this would be a person who would engage in some level of hormesis from a nutritional standpoint. In contrast, this individual would eat 6 or more times per day, have late night meals. Most of in terms of what the meals would be comprised of would be high-fat, high-sugar foods, and there would not be much of a fasting period. And so they highlighting, again, the when you eat, what you eat, as well as how much you eat and how often you eat, and the changes that could produce. And so when we think about fasting, there is more and more evidence coming out that a lot of times people ask, is it the fasting itself, or is it the fact that you don't eat as much because you're limiting the time frame in which you're eating? And I think the answer is both. This study I'd like to cite because in this study what they did was had male mice consume the exact same amount of calories and the exact same type of calories in 3 different conditions. One, they were able to eat 24 hours all the time ad libitum. Another, they underwent 13 hours, but they only ate during a 13-hour period. And then the third condition, which was the calorie restriction condition, where they limited the amount of calories that the mice consumed. And so what they found to me was pretty eye-opening. This was done at 2 different sites, and I'll just show you the graphs. So in this case, these are survival graphs. You can see the rats that engaged in calorie restriction, they did live the longest. And we know this from many studies that calorie restriction leads to healthy longevity across a variety of species. We don't know if that applies to humans yet, but what I wanted to focus more in on was this blue line, which showed or compared the survival of the rodents who restricted the time period only in which they ate the calories compared to the black line. As you can see, the average lifespan was, I think, approximately 11% greater for the rodents who consumed their calories within a 13-hour period versus who ate ad libitum. So to me, that made the point that there's something about the fasting period itself and not just the reduction in caloric intake that could be associated with intermittent fasting. Now, why? What is it about the fasting that does this? And here on this figure, I present some of the potential reasons that, in this case, time-restricted eating, which is on a daily basis restricting the time period in which you consume calories, some of the changes that we know are associated with doing this, and most people would probably enjoy these beneficial effects, including improvements in blood pressure, potentially reversal of type 2 diabetes, or at least lowering of the fasting glucose, lowering of blood cholesterol, reversing or reducing fatty liver disease, potentially affecting obesity, increasing autophagy, improving gut health, and improved sleep. Now, this was a summary of findings from preclinical studies involving animals, but more and more research is coming out in humans supporting many of these positive effects. And then, if that wasn't enough mechanisms, this next slide may be the overwhelming, and I'll just ask that you focus on the top box for the moment. The point I wanted to make here is that just like exercise, intermittent fasting can present our cells with a bioenergetic challenge that moves us closer to the ketogenic state, okay? And so that would be considered a switch from using glucose to ketones for energy. And you can see a number of other positive cellular changes that are associated with that switch. And that's an important switch, but also potentially when we then switch back and we undergo rest periods involving eating and sleeping, our body actually repairs tissues, and that's when the cellular adaptations are taking place, and ultimately can lead to cell growth and plasticity, and over time lead to a long-term adaptation of resilience and disease resistance. And so I think that this highlights at the biological level many of the positive cellular changes. Now, if that was too much science for you, I'll sum it up with the words that Mark Twain said, which is, a little starvation can really do more for the average sick person than can the best medicines and the best doctors. And so that's another way of saying what I was just showing you in terms of the review findings. Okay. So this is a figure I like to show because it highlights, in my opinion, that there are many potential sources of hormesis, or many potential ways in which we can activate the cellular process of hormesis and become more resilient. And you can see, obviously, physical exercise, sun exposure, cold exposure, calorie restriction, plant phytochemicals, heat exposure, intermittent fasting, caffeine, maybe a small dose of alcohol, potentially the ketogenic diet. So the point, though, is that it's about the dose of each of these. Any of these can be potentially harmful at too high of doses, or again, potentially not lead to many adaptations at too low of doses. But in the right dose, these can lead to positive adaptations. So I'll illustrate how this can look. For many individuals, the lifestyle that we're living involves relatively low levels of hormesis. This is an example of a person who would not be exercising, who would be consuming fast food or unhealthy foods pretty regularly, and that's their typical diet, and then during their free time would spend time watching TV. So there's relatively little stress or challenge in their life, and as a result, their energy level, in this case the battery, would be relatively low because there was never sufficient challenge to produce positive adaptations. In this case, this is a person who would be exercising, but maybe they're not eating such a great diet, but they do spend some time challenging themselves mentally. So that does lead to somewhat of an increase in their energy level compared to the other person. Similarly, this person doesn't really exercise, but they do practice intermittent fasting, and they do practice challenging themselves cognitively. So as a result, they experience some energy, but maybe not the full potential. Whereas in this case, this person does challenge themselves through exercise, practices intermittent fasting or some form of dietary challenge, and also engages in regular cognitive challenges. And as a result, their energy level is higher. And so to conclude, hormetic stressors, by that I mean temporary challenges, are critical to our health and survival. At least I hope I've convinced you of that. There are a variety of options to choose from, with each of them having their unique effects, and exposing ourselves to multiple types of hormetic stressors will likely lead to better adaptations over the long term. And because the stressor is so individualized, there is not going to be a one-size-fits-all approach. It's all about what works best for you and what produces the positive adaptations for you at this moment in time. So with that, I will say thank you very much for your attention, and I look forward to your questions.
So, do we have questions from the floor? Great. I'm going to toss this to you. Can you catch it? Oh, you got a cast on. Oh, my gosh. I am so sorry.
That's okay.
I didn't see yours. Beth, I should have asked you.
We're all physically challenged in this row. You mentioned restricting calories. And the question I have is, you didn't mention the quality of the calories. And I'm interested to know if that was considered in your study.
Great question. And I only didn't go into much detail about the quality of the calories because of the focus was on the variety of stressors, but there's no question that the types of calories, the three components of nutrition being the when you eat, the what you eat, and the how much you eat are all very important. So the what, in terms of the types of calories, absolutely has a role in affecting our health, but also our ability to recover from the hormetic stressors. I could probably give a whole talk on the what you eat and the what not to eat. What I will say is that within the field of nutrition, there's much more agreement on what not to eat than what to eat. I think we can all agree. Earlier I was asked, should we be eating fried foods, and should we be eating donuts? And I think most people would pretty much say those are probably not going to be health-promoting foods. But if we wanted to spend more time at some point talking about the what to eat, I'd be happy to.
Catch?
Hi, thank you.
Sure.
Regarding the intermittent fasting, is it equally beneficial to not eat for 2 non-contiguous days during the week versus a daily 16 8-hours?
Great question, and the answer is, it depends. It depends on the outcome you're looking for. For example, if your goal was to enhance that cellular process of autophagy, then 2 days in a row would likely lead to great... Non-contiguous days or every day? Is that your question?
So as opposed to eating for 8 hours.
Sure, okay. So comparing what would be called a 5-2 type of intermittent fasting versus the time-restricted eating approach to intermittent fasting. to some degree, it's still, my answer still stands to some degree, because on the days in which you don't eat too much on those 2 days, you would likely activate the process of autophagy to a higher level. But if you were to engage in time-restricted eating every day, you'd activate it to a lower level every day. So to answer your question, it's difficult to say one is necessarily better, but what I would say is the one that works with your lifestyle is the one that's going to end up being better. Yeah.
Just to segue on what her question was, mine was also about when do you fast and how often do you fast. But what do you define as fasting? Is it liquid? Is it solid? Is it just nothing?
Good questions.
Yeah.
What I define is maybe not the final definition, but many people have debated what exactly it is. And in general, most people would agree that you can have some liquids, such as water and or coffee, while you're fasting. Coffee, as long as it doesn't have, it's not from Starbucks and has sugar and milk and cream and everything else. So generally speaking, fasting is the period in which you're not consuming calories from food or beverages. So that's how we would define it. But to expand and what I wanted to say further with your question is it's really important to determine how adapted each person is before you start fasting and gradually expand the fasting window. I have many people have told me, oh, intermittent fasting didn't work for me. And I ask them what they did, and they say, well, I tried to do 16 hours straight. And to me, that's similar to if you're not a runner and you go and you try to run 3 to 5 miles straight, before you've adapted and allow your body to adapt. So that's a little bit of a segue, but I wanted to at least bring that point to the group. Yeah.
Got one more?
Hi, I've been studying health span almost as long as you've been around. No, long time. And right now, the question I have is about protein. It's hard. I mean, they're increasing the recommended amounts of protein, especially in the aging. You touched on it a little bit, but do you have any insights in how we can get enough protein in that shortened eating window?
Excellent question. And I think that's such an important point about why we want to consider taking in protein, because earlier I talked about with lean tissue loss, our metabolism starts to decrease, and that can set us up for unhealthy weight gain. And so protein is what helps us maintain the lean tissue, right? And so there's two things. One, you want your body to be able to absorb and convert that protein into lean tissue and not into fat, right? And so first of all, by engaging in some level of exercise prior to eating, you increase the chance that your body will convert that protein into actual lean tissue. Now, to be able to get sufficient amount of protein in, let's say, an 8-hour eating window, if you chose to engage in intermittent fasting, I think it's quite possible to consume 3 meals during that time period and to consume somewhere between 25 to 40 grams of protein per meal, which for most people would convert to the level of protein needed to maintain their lean tissue. What I would say is that you just have to be plan accordingly and think through the types of meals that you're going to eat, and with each time you eat, try to have some protein with each meal. Yeah, and if you do that, generally speaking, you'll probably feel better too.
Okay. Thank you so much. It was
Sure.
a great talk.
Thank you.
My question is, I've been a proponent of intermittent fasting since I've read Jason Fong's research, but now there seems to be a whole bevy of research out there about women and hormones in intermittent fasting. do you have any advice to offer that we shouldn't be doing it? Because I do 8 and 16, so, you know, how does all of that play in, or do you have any information on that?
It's a really good question. A couple years back, and often I am asked a similar question after these talks. So a few years back, I really looked in the literature to see what I could find on fasting for women in particular, and if there was any real concerns. And at that time, I didn't find any study in humans that would suggest there's a real issue for women to do this from a hormonal standpoint. There was one study in rodents where they had the female rats fast for a very long period of time, and that ended up affecting their menses. And because of that study, it got widely publicized, and the conclusion was, you know, women should not practice intermittent fasting. My opinion is that was not the right conclusion based on that study. So, to my knowledge, there's no reason that women couldn't practice time-restricted eating, but and just like men, they should do it by checking in with themselves to progressively increase the time in which they fast, and so that the positive adaptations can occur. Yeah.
We got, okay. Here you go.
That's the microphone. Wow, a big microphone. Hi, I'm Linda. I came here thinking it was going to be more psychology stuff. Forgive me, I didn't read all the details. However, I love everything you said. I'm a hyper type, so I used to run, etc. I may have to talk to you privately afterwards because I need to ask, have you heard of CRPS? That is what I've suddenly been diagnosed with from surgery. This is very stressful. That's why I came. But I absolutely say 2 meals a day works for women. You have to do it more gradually. Yes, I absolutely agree with
Thank you for your comment. I'll say, I haven't heard of CRPS as a syndrome, but what I will say, and it sounds like you're probably already aware, is that stress, chronic stress, I know I talked a lot about the value of temporary stress, but chronic stress is not good for anyone. And we know that chronic stress can decrease our immune function. And so all I can say is, to the best of your ability, to try to catch yourself if you're feeling stressed with engaging in other processes that can help you feel less stressed. That wasn't your question, but I wanted to make the point about chronic stress. Yeah.
complex regional pain syndrome.
Oh, okay. Okay. Thank you.
Time for one last question. You're the lucky guy.
These people that are inactive and then they start being active will notice a fairly significant weight loss for a short period of time, but after a period of time, it seems like that weight loss doesn't continue to happen. Have you had any experience with that?
Yes, and that's unfortunately a common experience, and it goes back to what I mentioned at the beginning of the talk when we were talking about total energy expenditure from the various sources. And so physical activity, by increasing your physical activity initially, you're increasing your total energy expenditure, and that should result in a weight loss if you don't change your calorie intake. The challenge is that it's difficult to not increase your calorie intake proportionally over time as you start to increase your energy expenditure. And so I think this is one of the ultimate challenges, is trying to just pay attention to both sides of the equation, the energy expenditure and the energy intake, and to keep that lean tissue as high as possible to then hopefully lead to a gradual and consistent weight loss. But it's not easy. I don't pretend that. Yeah. I hope that.
I'd like to thank Steve again for joining us back in Ocala.